Hello everyone and welcome back to the channel. If you're new here, welcome. And today we'll just continue with our basics of static equilibrium with a second example. So without further ado, let's jump into it. So right now this question is simply a truss system, and it has all the same thing as the previous video, except it's just looking like a bit more complicated. All right, so of course the question is just to find the reactions at support A and C, okay? And that's what we're just going to work through. So how exactly do we approach this problem? Well, it's exactly the same as the previous problem, all right? First, we have to identify what kind of supports are we looking at, right? There you go, what kind of supports, all right? So in this case, we have point A, which is a roller support, which means that it is only resisting one force, and that is the vertical direction, okay? Since once again, if you imagine these as wheels, little wheels on the bottom, if you pull it horizontally, it will move, all right? And this one is a hinge support, all right? So it is resisting forces both in the vertical and the horizontal directions, all right? So now that we have the support reactions listed, AY, CY, and CX, we can just begin to find the reactions. So here we go. How I would approach this problem is very simply just do the moment about C. All right, so just imagine C as your little door hinge, as just an analogy, and you're just spinning things. I guess we should keep it consistent counterclockwise, right? So set counterclockwise as positive, and the moment around that equals 0, which means that it's not spinning into space. It's just in equilibrium, all right? So how you would set up this equation is look at which way the 18 kilonewtons is pulling this structure in, all right? Now, we don't have to consider any of these diagonals. Don't let those confuse you. It is just simply a system, all right? So we're using this 18, right? 18 kilonewtons, and we are simply imagine pulling on it. So imagine pulling on this, and it spins the entire thing this way, right? And since we defined counterclockwise as being positive, if this 18 kilonewton force spins it clockwise, therefore it is negative, all right? And when you're doing moments, be sure to always just keep this convention in mind. It will be very useful later on when when the problems get more confusing and you have a lot more forces. All right, so once you have this 18 kilonewtons, the next step is to figure out the distance. All right, now what distance are you going to use? Are you going to use, let's say, a kind of direction, a diagonal distance, or are you using this distance, or are you using this distance, or maybe this distance for some reason? What distance are you using? Well, for this, we have to just recall that the best way to push on a door is simply perpendicular, right? So it's just the force, the distance that is perpendicular to the force that we need to take account of. So this would just be the 6 kilonewtons plus the 6 kilonewtons. 6 meters plus 6 meters. So for a total of 12 meters. So that is from this force and perpendicular to this force, 90 degrees here, and then all the way to point C. All right, simple enough. So negative 18 times 12, right? That is the moment caused by this 18 kilonewtons. All right, now this AY, sorry, that dash might have been confusing as a negative, but this AY is also spinning the system this way. If you just imagine the support wasn't there and you just pulled it, pulled the entire truss, right, it would just spin clockwise, right? So in this case, it would also be a negative, right? You can write it as negative, and then AY times the perpendicular distance, all right? Perpendicular distance being 8 and 6, all right? That's 8 and 6 meters. That's, once again, this line, imagine there's a line here, imagine there's a line here. 8 plus 6, so that's 14 meters, all right? We'll just put the units there just for clarification. And that is your sum of moments. That's all the forces contributing to, I guess, the spinning or resisting the spin of this entire system. So that's just 0, right? Because it's not spinning into space, right? Okay, now simply, what we now need to do, very simply, solve for AY, right? So let me just plug that into my calculator. 18 times 12, so that's 216 minus 14 AY equals 0. And sorry, this should be a negative as well. All right, just keep in mind your positives and negatives. All right, so that means that AY, right, is now equal to 216 divided by 14. That's roughly 15.4, and your units are in kilonewtons because those are forces. All right, now let me just ask you, is this positive or is this negative, right? So you would get a negative answer. And what does this mean, a negative answer? Well, instead of AY going upwards as we defined here, it is simply going downwards, all right? I'll draw another diagram at the very end when I summarize it, so we make sure. But let's just say for now, AY is still defined as upward, and we use this negative value, okay? So the next step is just simply sum of forces to figure out the rest of the items, all right? So sum of forces in the x direction with towards the right being positive equals 0, all right? Now, this just means that all the forces that are going horizontally, so namely this 18 kilonewtons and Cx, just have to be equal to each other, all right? So if we define going to the right as positive, it's 18 kilonewtons plus Cx equals 0, all right? Sum of forces and then 0, all right? Always like that. So Cx would just equal negative 18 kilonewtons. Very simple, right? And then finally, sum of forces in the y directions, all right, equals 0, all right? So what are my vertical forces? Well, we have AY over here and CY over here, right? So all we have to do is AY plus CY. Again, upwards is being defined as positive, so we just have this convention, AY plus CY equals 0, all right? And then all we have to now just define is AY equals, or you can put it this way, negative AY equals CY, right? And since AY equals negative 15, right, CY just equals 15.4 kilonewtons, all right? So it's simple as that. So let me just highlight all the answers and just write one more summary, all right? Ooh, that is a very thin highlighter. Ooh, let me change that. So 15, 15, and 18, okay? So, once again, if we just adjust and do a final check to make everything make sure that everything makes sense, all right? So, if I just, clean this up a bit, and we look at our forces, all right? If we initially defined as upwards and to the right as positive things, then everything that is negative must be going in the other way. So it is simply, let's start with AY. AY equals 15 kilonewtons, 15.4 kilonewtons that way, right? And that is the reaction at AY, whoops, okay, going downwards, right, because it's negative. And CY equals 15.4 upwards, right, because it's positive. And finally, x is negative 18. So negative 18, right is positive, left is negative. 18 kilonewtons. All right. So that just means, what this really just means is that if you pull on this entire thing with 18 kilonewtons of force, to hold the structure still, the support at A has to be holding it down like this, right? And in order to, of course, hold this 18 this way from keeping the system going, like, you know, translating like this, it would be holding it back this way, right? I should get rid of that negative. It might confuse some people. But it is holding it back to the left, right? And in order for, I guess, because this is spinning this entire system and this AY is holding down the spin, right? There is an additional downwards force here, so therefore there has to be just some 15 kilonewtons countering it upwards, all right? So that's just really of an intuitive check to kind of see if you're doing these questions right. And as you get in more into it, I'm sure you can, of course, figure that out more quickly than me just explaining it. But yeah, so I hoped this video has really helped you. If you did manage to have, if you learned something, that's great. I'm here to help, so more videos coming soon, and I'll see you guys next video. Thank you.